So that should be the mean absolute deviation. And so we're going to see what exactly does that mean when we're talking about mean absolute deviation. Let's see. So oh my gosh, give me a second. Okay, so let's say we have this set of numbers and we have 21, we have 0, 36, 30, 13, and 32. So let's say we have those set of numbers. Now remember that we've been pretty much practicing how to find the average of those numbers. So in this situation, how do we find this average?
First, you have to put the numbers in order.
Right, so I mean, when we're talking about the median, we would put them in order, but if we're just talking about the mean, sorry, what was that, Haley?
You don't have to, just add them all together.
Right, so when we're talking about the mean, we're just gonna add them all up together. There's really no need to put them in order. When we're talking about the median, yes, but in this case, it's not. So if we're just trying to find the average, and this is, no, we had started this, but this is going to be our step one. Our step one is to find the mean, okay? I know we're gonna start doing this this poster in school, but we're not gonna get the chance to do that. So our step one is finding the mean. And again, I just like to break this down into a couple steps because it's a lot, it can be a lot of work, but it's not hard. It's just learning the steps. So step one is to find the mean. So in this case, we add them all up. We have a total of 132. And now we're gonna divide that, what are we gonna divide that by? Our total added is 132, but we're gonna divide it by what?
How many numbers are here? So
6.
6, yes.
6.
We have 1, 2, 3, 4, 5, 6 numbers, okay? And we also include that 0. And I gotta tell you, like, if you ever wonder why, like, you have a good grade in class and then if you're missing an assignment, it'll drop down a lot, is because zeros really affect an average a lot. So just so I can tell you, like, we can even make that comparison here right now. So let's say we're gonna divide this by 6. So 132 divided by 6, the average is 22. Okay. Let's say we didn't include that 0 and we did 132 divided by 5. It's 26.4. Well, not a lot in this case, but you know, you can see that it drops down 4 points because of that 0. But anyways, it's not really what we're focused on. You know, just kind of get there. Okay. So anyways, our average is 22. So we're going to keep that number in mind, 22. We're going to keep that number in mind. All right. So let me know when we're ready to move on.
I'm ready.
All good? Okay. So that was step one. Our mean is 22. Okay, so with step two, we want to find the differences. Step 2 means that we're going to find the differences. So we're going to find the differences. So when I say find the differences, what does that mean?
divide or subtract.
Subtract, that's right. So when we're talking about finding the difference, we're subtracting. That's what we're doing, okay? Now here's the thing. I don't care about negatives or positives, okay? I just want to know what the difference between the numbers is. And so if you guys remember, we're gonna do something similar in school, but since we're not gonna be able to, you guys remember when we went around with the juniors and we were asking how many candies were in the bin? So the answer ended up being 136, okay? 136, and let me see, actually, yeah, the answer was 136, and from you guys, well, Kaylee, you guessed 85. Haley, you're a little bit off. You guessed 30. And Remington, I believe you guessed 77. Okay. But here's the thing, right? Let's say 136 was what we're aiming at. Now, does it matter if there was actually two people that tied for the correct answer? So does it matter if I go over the 136 or if I do under the 36? Does that matter?
No.
Why not? I mean, what's our goal here? What's our goal? Like, who's going to be the winner of this?
Whoever guesses the number.
Whoever guesses a number or comes closest to it, right? So I had a guess that was 132. And then I had a guess that was 140. Now that's what I mean when I say that they tied, right? Because what's the distance between, or what's the difference between these two? So what's the difference between 136 and 132?
4.
4.
Well,
And then between 136 and 140?
4.
It's also 4,
4.
right? So that's a distance between the two. Okay. So this is going to bring us to the concept of absolute value. Okay. And that's kind of like the second part in our MAD abbreviation. It's mean and then absolute, right? So when we're talking about absolute value, we're talking about the distance from 0. So let's look at a number line. This is 0, and this is 4, and this is -4. Okay. So the question is, what is the distance between 0 and 4? What is the distance there?
4.
4, right? What about the distance from 0 to -4?
4.
4, right? Do you notice neither of those is negative or, I mean, it's positive, but neither of those is negative, right? Because what we're worried about is the distance from 0 to the number, okay? So absolute value is written like this. 2 little lines around the number. So if I say, what's the absolute value of 4? The absolute value of 4 is 4. So what would be the absolute value of -4? The absolute value of -4 is also 4. So basically, we use absolute value because we don't care about negatives when we're talking about the differences in this case. So we're going to use the absolute values to turn everything that is negative into a positive. Okay, and that's essentially what absolute value is. Okay, so let me give you guys an example. What do you guys think the absolute value of, I don't know, let's say -32 would be?
32.
Positive, yes, positive 32, and that's the important part. What about the absolute value of 10?
10.
10. And what a lot of people kind of get confused is that if it's a positive inside the absolute value, they think it's negative. But that's not the case. Anything that is inside the absolute value, no matter what it is, will turn into a positive number. So if it's a negative, it turns positive. If it's a positive, it'll stay positive. Okay. And here's why it makes a difference. Okay. So let's go back to our problem. So back to our problem, remember our mean was 22, is that right? So here's what I'm gonna do. These are our numbers, 21, 0, 36, 30, 13, and 32. Now I'm gonna find the difference. So I want to subtract my mean from every single one of these. So 22, I subtract 22 from each of these. Okay. Now, like I said, I don't care about the negatives. So what I'm gonna do is I put them between absolute values. Okay. So let's start finding the differences there. Okay. What is 21 minus 22?
1.
It'd be, well, more specifically, a negative 1. But yes, that's correct. What about 0 minus 22? So what is our 0 minus 22? Okay. So what should be that? 0 minus 22?
$22.
And more specifically, negative 22. Okay. So let's find the answers all there. So 36 minus 22, that should be 14, right? 30 minus 22 should be 8. 13 minus 22 should be 9, negative 9. And 32 minus 2 is 30. Okay. So you can see some of those are negative, some of those are positive. But because of the absolute values, I'm going to turn every single one of those into a positive. So 1, 22, 14, 8, 9, and 30. And we're going to add them all up together. So 1 plus 22 plus 14 plus 8 plus 9 plus 30. It will be equal to 84. So our step 2, find the differences and add them together, will be 84. Now again, it looks like a lot of work, but we'll simplify it a little bit more when later on we'll just we'll make it a little bit simpler. Okay. So this was actually, I kind of put 2 steps together here. Let me just, are we ready to move on here? Can I clear this? Yeah. So our step 3 was actually to add all the differences together. So I already kind of did that, but again, add the differences. So in this case, our differences were 1, 22, 14, 8, 9, and 30. So 1 plus 22 plus 14 plus 8 plus 9 plus 30 would be equal to 84. So finally, our step 4 is going to be to find the mean again. So this time our total is 84, and we're going to divide it again by 6. So 84 divided by 6 is going to be equal to 14. And that is how we find our mean absolute deviation. And again, it seems like a lot of work, but once we're going to start, kind of organizing this in a chart, so it should be a little bit easier to see, okay? But now let's interpret this, okay? Let's say, well, our original numbers were, our original numbers were 21, 0, 36, 30, 13, and 32. Now let's just say that, back to the sports metaphor, let's say that that was our points in 6 games. Let's say, I don't know, can this really work, Haley? I mean, can you go from 21 points to 0? Is that how it usually happens to you, or?
That's a big difference.
But yeah, I mean, obviously, it honestly, I've seen it kind of happen, and it's okay, sometimes, like, if you have an off game, right, that you don't score any points at all. But let's just say we did 21 points, and then the next game we did 0. But then we realized, oh, we did terrible, so we went up and we did 36 points again, and that's awesome. Then we went down a little to 30. Then our next game, not so good, it was 13 points, and then finally we ended at 32. So over 6 games, my average was 22 points. So again, remember, we can, like with an average, we can expect 22 points would be what you can expect from me during a game. Okay? It could be less than that, it could be more than that. The problem here is that the numbers kind of fluctuate a lot, right? Why do we go from, you said there was a big difference from 26 points or from 21 points all the way down to 0, and then back up to 36, and then down to 13, and then back up to 30. That's a lot of fluctuation, right? So it goes up and down a lot, okay? This is what the mean absolute deviation is supposed to do, okay? It's supposed to kind of take that away and show us whether our data is reliable, right? So if I tell you I average 22 points a game, according to my mean absolute deviation, that's not very reliable, because my goal is to be as close to 0 as possible, okay? So if anything above 10 is pretty much like trash, the statistics don't work, right? So for example, if I tell you I average 22 points, but then you see my mean absolute deviation is more than 10. So what are you gonna tell me? Do you think that's reliable? Like, do you think you can actually expect 22 points from me, or what do you think?
No.
Not necessarily, right? You could probably, like, I don't know. I mean, what this 14 represents is just basically how reliable is my data. And obviously my data is not very reliable because my points fluctuate way too much, okay? So let's say if I was a little bit closer, let's say, let's just say over the few games I did 20, I did 21, 20, 20, 22. I did 24, 20. So let's say, I don't know what this mean is or what this average is, but let's just say the average is 22 again. All right. Do you think this is a little more reliable?
Yeah,
You see this is a little more reliable. Why?
because the numbers are closer together. You have an average.
Right. So our average is closer to that 22. So now you can actually expect, instead of me going from 21 points down to 0, I just went from 21 to 20, you know? So it's a little bit closer to that actual average. So these numbers are probably a little more reliable. Now, when I calculate the mean absolute deviation, it'll probably be closer to 0. Okay. I'm not going to do that right now because it's going to take a while, but yeah. So, okay, let's see. Okay, guys. So